Okay, record on this computers. Then, okay, ready to start. Okay, we will go to our next lectures. Okay, so today we are going to talk about the ignition system. The ignition system. Okay, so basically there are two conventional ignition systems. The first one we call is the battery or coil ignition system. And the second one we call is a magneto ignition system. The first one is the common one that you usually see in normal passenger car, trucks. The second one, right, you will see it in the racing car. The racing car like a Formula One or a very high-speed car like a Ferrari, something like this. Right? They're gonna use this second system. Okay. Both systems, no matter if it is a battery or coil ignition system or the magneto ignition system, both systems will work on the mutual electromagnetic induction principles. Right? What does this mean here? Electromagnetic induction principles, right? It's the work between the electrical conductors and the magnetics in order to induce the current. And so the current will happen because of these two work together. Okay. The electromagnetic or magnetic inductions, right, is the production of an electromotive force, which normally we call is a voltage. The voltage here, right? That will go across an electrical conductors, right? Our electrical conductor here is a coil of wire in a changing magnetic field. Right. So with the coil of wire and magnetics, right, changing of the magnetic field, right, it will create the voltage and induce the current. Here. Cannot move the slide. Okay. This is what happened. The principle. This is how the principle go. Right. We call it a Faraday law of inductions. We have a coil of wire and the magnet here, right? That moving in and out in order to have a change of the magnetic field here, and then you will see that you have the voltage go across this coil here. Okay, so let's first talk on the first system, the battery or coil ignition system. This ignition system is divided into two circuits. Right? The first circuit we call is a primary circuit. Right? The primary circuit is shown right here. Right? In the primary circuit, we will have a battery. This is the main source of the power here. The battery, right? It can be either 6 or 12 voltage, but normally, mostly you will see 12 voltage. You don't see 6 voltage battery here, right? And it have or may not have an ammeter, right? This is the current meter in order to see how much is the current that happened. And you have an ignition switch. This is the car key, right, that you insert in and then you switch on your engine, right? This is the ignition switch. And you have a primary winding, right? The less color here is a primary winding. Right? This primary winding have very small turn, about 200 to 300 turns of the gate wire, right? The gate wire, we normally we have the standard for the gate wire that will tell you how thick this wire is, right? And it normally tell you in the number, right? For example, this is 20 SWG. The SWG stand for sharp wire gate, right? Or AWG, American wire gate here. Okay, so if the number is small, the thickness of the wire is thick, right? So this one is 20, right, which considered to be small, right? So it's a thick one, right? So we have primary winding, right, on the coil that have only about 200 to 300 turn here, right? This is the primary winding. And then we have a contact breaker and a capacitor. This contact breaker will work according to the motion of the cam to open or close, right? And this capacitor is the device that store the current, right? So in here you can see that if this contact breaker close, right, we have an electrical flow to the capacitor here, right? So the capacitor will store this electrical current within itself, right? And when this breaker point open, right, it will discharge the current back to the primary winding, okay, to help the primary winding, okay. So this circuit, if you look at the overall, right, from the battery, ignition switch, the primary winding, all the way to the breaker point and to the capacitor. All of these are working on a low voltage, which is 12 volt here. Okay. Then we have the secondary circuit. The secondary circuit here, right? It consists of the secondary winding, which is inside here. If you see this picture, the secondary winding is inside the primary winding, right? It has a much more turns than the primary winding, right? See, you have 21,000 turns of 40, right? 40, when the number is large, it means it's thinner, right? The wire gate here, the gate wire here, right? For the secondary circuit, right, is much thinner than the gate wire in the primary circuit, right? This is 40 SWG or AWG here. Okay, so, and this I give you the wire gate diagram here, right? That you can see higher and higher number, you can see thinner and thinner of the gate, of the wire gate here. Okay, gate wire, not wire gate. Okay. Okay. So in here you see the primary circuit and the secondary circuit, right, in the coil. Yeah, the whole thing here we normally call is a coil, right? The whole device here. Okay. These two circuit, right, is the primary and the secondary circuit. They are connected with each other at the bottom end here. At the bottom end here, right? And the top end of the secondary winding, which is here, right, will connect to the center of the distributor loader, right? So the bottom end is connect with the primary winding. The top end is connect with the distributor loader. The distributor loader look like this. Okay, we didn't show you inside, but the next slide we will see what inside this distributor loader. So here is the cap of the distributor loader, right? So inside the distributor loader, we have a loader that will rotate. This loader will rotate and then make contact with the contact point inside the loader, inside the distributor loader, and it will connect to the spark plug. Right? And this spark plug is in the cylinder head. So every time that the loader make contact with the contact point, right, it will send the current from the secondary winding to the spark plug. And since the secondary winding have much more turn than the primary winding, so you can expect that in the secondary winding, right, the voltage is much higher and also the current. Okay. So this show you the loader inside the distributor loader, right? that it will make contact within the distributor loader, and then every time that it makes the contact with the contact point, it will send the current to the spark plug here, right? So that we will see an arc come out from the gap of the spark plug here. And this cam here, right, is to provide the timing. This is not the camshaft, it's just a cam, okay? It's cam that will provide the timing to each spark plug by open or close the contact breaker. Right? So every time that it close, the current from the capacitor will flow to the primary winding and help the primary winding, because at the same time the primary winding also have the currents from the battery, right? And when this primary winding have the current, it will induce a high voltage inside the secondary winding, right? So the secondary winding will have one very high voltage, 21,000, right, voltage, that enough to send the electric current to the spark plug and then create a spark, right? The electric can jump over the gap in the spark plug. Okay, this is another pictures. Let's see you show you the ignition coil system. Here we have the ammeter showing here, and this is another type of the contact breaker. This is how the contact breaker, actual contact breaker is in the system. Yeah, and this is the cam. Okay, and this is the overall diagram of the battery or coil ignition system. The overall diagram here. See, we have the currents go from the battery. When we closing the ignition switch, the current will flow into the primary winding. Okay, with the contact breaker open, with the contact breaker open, okay, the current here will drop. Right? So the secondary winding will have the high voltage, 21,000 turn, right? And then go into this distributor loader. The voltage is about 20,000 to 30,000 voltage showing here. Okay, and make electrical go over the spark plug here. Okay, this is how it works. It's wrap up everything that I just mentioned, right? So that you will understand by reading. Okay, so by closing the ignition switch, right, when you start your engine, the engine in crank, that means the engine start to rotate. Okay, as soon as the contact breaker close, right, we will have a low voltage that will flow, a low voltage current will flow through the primary winding when the contact breaker close. And then when the contact breaker open, the magnetic field that happened in the primary winding collapse. And because of this collapsing magnetic fields, right, the currents will be induced in the secondary winding. Okay, and since the secondary winding have more turn, right, 21,000 turn, the voltage will go up to 28,000 to 30,000 voltage here. And this high voltage current, right, will brought to the center of the distributor loader, and the distributor loader will rotate and then supply this high voltage current, right, to the spark plug, depend upon the engine firing order. That means which cylinder that need to have the spark come out from the spark plug, right? And when the high voltage current jump across the spark plug, it will produce the spark. And then the fuel mixture is ignite, fuel air mixture is ignite, and then combustion start, and product of combustion expand, and then produce the power. So this is overall how the system works. Okay, start from closing the ignition switch, the electric currents go to the primary circuit, primary winding. And when the contact breaker open, the magnetic field inside collapse. And because of the magnetic field collapse, the secondary winding will induce the voltage, high voltage, because of more turn of wire in the secondary winding. And then this voltage will go to the distributor rotor. The distributor rotor have the rotor that will make a contact with the contact point. And then when it make with one of the contact point, it will send the high current due to a high voltage here to the spark plug, so that the electric can jump over the gap and create the combustion in the cylinders. Okay. How about the function of the capacitor that we have in here? Right? I did mention earlier already. Right? This capacitor, right, we have to have it. Not just because if we don't have it, everything here not happen. Right? Even though we don't have the capacitor here, right, we still have a high voltage here. But this capacitor is here because it can help reducing the arcing at the contact point here. Right. So keeping the lifetime of the contact point or the contact breaker here longer. Okay, longer. Right. So when this one open, right, when the contact breaker here open, right, you see the current from the battery go to the capacitor. Right, the magnetic field here, correct? And this capacitor get fully charged because of the current from the battery. And when it's closed, this capacitor start to discharge the current in here. So it will help build up the current in the secondary winding. Right? So there are two advantages by adding the capacitor in our battery coil or ignition coil system. One is to help reducing the arcing at the contact point, the contact breaker. The second one is to help building up the high voltage in the secondary winding. Okay, so in conclusions for the battery or coil ignition system, right? In the two-stroke cycle engine, right? We have the cam in our system, right? So the contact breaker cam and the distributor rotor will be motor at the same engine speed, because for the two-stroke, every round of the crank we need combustion. Okay, but for the four-stroke here, there will be motor at half of the engine speed, because every two rounds we need just one combustion. Okay, so that is for the battery coil ignition system. This system can provide a good spark at low speed of the engine. Okay, so if you run the engine at the low speed, it gives you a high current. That means you have a good spark of the spark plug at that conditions. Okay, it needs more space to occupy the system. Okay, it needs more space because we need to have a place for the battery. Okay, and it requires recharging of the battery. Right, so since the battery keep providing the currents to the system, right, so it have to be recharged. Right, so what do we do for the recharging? We use the chargers or the alternator, right, to help charging the battery, recharging the battery. Okay, again, cannot move the slide. Okay. Okay, and this is what you see in your engines, the alternator or the charger. Right? In Thailand, normally we call it a die charge. It's different from die start. This is a die charge. Die charge is mean it will be a charger and charging the electricity back to the battery, right? When it run by the engine. it become a discharge. But at the beginning, this one will be a die start because it will receive the currents from the battery, right? And then it will start running the engine, right? To help the engine run at the very beginning, right? So we have, sometimes we call it a die start, or sometimes we call it a die charge. It depends on how it functions. Okay, that is the first system, the battery or coil ignition system. Okay, the second system is called the magneto ignition system. Right? In this system, we also use the electromagnetic fields and also the induced current principles. They use the same principles in order to develop the high voltage, right, to create the spark. Okay, this is the picture of the system. One thing that you can notice in this system is what? You don't see the power supply, right? This system have no power supply. You don't see the battery in here, right? It consists of a magnet here, right? And a magneto. This magneto is a permanent magnet AC generator. This magneto here, and this magnet, right, is rotated, right? It's rotating here according to the motion of the cam here. The cam here also closing or opening of the contact breaker, which is here. Right. You also have the ignition switch and also the capacitor in here. Okay. The system can be either this magnet rotate and this magneto is fixed, or this magneto is rotate and this magnet is fixed. Can be either, right? Okay, for this picture, right, the magnet here is rotating and the magneto is fixed, right? And in the magneto, you see we have a primary winding, the red color, and the secondary winding, the dotted line here, right? So everything is much the same, except that we don't have the battery in here. Okay, we also have the distributor rotor here and the spark plug. The magneto that we have in here will produce and supply the required currents to the primary and primary coil here, right? So due to the rotation here, it will create the current to the primary winding. Okay, as I already mentioned, system can be either rotating magnet with fixed coil or rotating coil with fixed magnets. Okay, other remaining arrangement is the same as the battery or coil ignition system, except that no battery is required, right? Because the system itself is capable of producing high voltage by itself. So the system is much more compact. No need for the space and no need the space for the batteries. Okay. And this is the characteristic of the two systems. Okay. Remember, I just mentioned that the battery coil, right? The battery coil system, okay, give you what? A poor, right, at the low speed, right? Poor spark at the low speed. So you have a high current here, right? And for the magneto, let's see, okay, the magneto give you a small current here. Okay, so at low crank speed, at the starting condition, the current that generated by the magneto system, which is here, is very small compared with the battery coil. Right? So it gives you a poor sparking at the start. Or in other words, you will have a starting difficulty. Okay, so in some system, when they use this magneto system, right, sometimes they have they add up some battery in the system in order to help starting the engine at the starting conditions. Right? but at high speed for this system, right? See, at high speed here, right, of the engine, right, it gives a high current. Right? It can give you a higher current. So that's why this system is good for the racing car, right? Because for the racing car, right, normal operation of the racing car is always at the high speed, right? Compare with the passenger car, right? That normal operation of the passenger car is normally at the middle speed, not at the high speed here, right? And when you look at for the battery coil, right, at the high speed, the current is much lower than the magneto system, right? That's why this battery coil is not suitable for the racing car because it provides or it gives you a lower current, right? And that means you will have a poor spark at the spark plug. Okay, the magneto ignition system can be divided into two, right? The first one is high tension or high voltage magneto ignition system, right? This system will include a single high voltage magneto, right? So we have only one high voltage magneto, right? And it will have an assembly of wire, which is the primary and the secondary, and a set of the spark plugs, right? It will use a rotating magnet, right? Instead of the battery, I have a primary and secondary winding, and the coil will step up the high voltage. Okay, so we have a high voltage here, right, before go to the distributor and to the spark plug. So that means what? That means when you look at this picture, the high voltage always go to the distributor. This is the same as the battery coil, battery ignition system or coil ignition system, right? Because the distributor here always receive the high voltage, which is what, 20,000 to 30,000 voltage here. That is the reason why we call it a high voltage magneto ignition system here, because the distributor here always receive the high voltage here. But for the low voltage magneto ignition system, right, for the low voltage magneto ignition system, right, we will try to avoid, right, to have a high voltage go to the distributor. Because what? Because we want to overcome the flash over that might happen in the high tension magneto. The flash over is what? Right? When this rotor moves from one contact point to another contact point, right? When it moves, it may have a flash, right, that come over because of the high voltage here, the high voltage that's still left over here, right? So we want to avoid that, right? And if the flash over happen, right, we may have a spark that jump to the long electrode or the long spark plug. Okay, so the low voltage magneto ignition system come in order to solve this problem, right? The magneto coil in this system will have only one winding, which is different from the high tension. For the high tensions, we have two winding, the primary and the secondary, right, at the magneto coil. But for this system, we will have only one winding, right? This winding coil will set up a low voltage, right, a low voltage here, in order to keep the flash over at its minimum, right, in order to minimize the flash over that happen, right? And since it have only one winding, how can this system can create the high voltage? It needs another device, which is the high voltage transformer, right? So they have to have a high voltage transformer that is an ordinary one that consists of the primary and the secondary coil. So they use this transformer in order to convert the low voltage, right, from this magneto coil, the magneto coil here, right, to high voltage that will send to the spark plug. Okay, so the system look like this. Right. In the magneto here, we have only one winding. Right. So because of one winding, that means we have the low voltage here go to the distributor. This will help minimizing the chance of the flashover that may happen in the distributor here, right? And then the rotor make the contact with the contact point and send the low voltage current to the primary winding in the transformer, right? And then the secondary winding in the transformer will create the high voltage and send it to the spark plug, right? So the high tension magneto system and the low tension magneto system is different because of this, right? First, the magneto for the low tension have only one winding instead of two winding, right? The second one, the low tension system need to have a transformer here in order to convert the low voltage to the high voltage. Okay. So these are the two conventional systems, right, that used many years ago, right? The battery coil ignition system, okay, and the magneto ignition system. The battery coil system you still see in the present passenger now, but now it's gradually changed. It's gradually changed, right? That means you will see less and less of the battery coil ignition system. Okay, why we have to replace this conventional ignition system? Look at the disadvantage of this conventional ignition system. Right? The first one is the arcing at the contact breaker point. Right? At the contact breaker point, we have the arcings, right, that result in what? Pitting of the contact breaker points, right? So that means longer and longer that you use system, right, the contact breaker point at the face of the contact breaker point, you will see a small tiny hole, many small tiny hole happen. Okay, so this will have an arc or create more arcings when it close and open, right? Because it's not smooth. The face of the contact breaker point is not smooth. Okay, so that's the first one. The second one is the poor starting of the magneto system, right? Because at the beginning, the engine speed is very low. When you do the starting of the engine, you see a low current that supply from the magneto system that will give you a poor starting, right? And then if you run the engine for a few thousand kilometers, right, the timing, right, for finding order or the timing for the spark plug to work according to the cycle in the cylinders, right, become inaccurate, which result in what? In more and more of the poor starting. Okay, and at the high engine speed, for the high engine speed, if your car use the battery coil system, right, the performance of the car is poor because the battery coil system will provide a lower current, right, a lower current at the high engine speed. The reason why it provides a lower current at the high engine speed because of the inertia effects in the moving part, which is the cam, right? When the engine moves at the high speed, the cam have to move faster and faster, right? And that create the inertia effects to the system. Okay, so the performance is poor, right, at high engine speed. Okay, and the last one is this two systems sometimes is not possible to produce the spark properly in a foul spark plug. That means if your spark plug is not in the good conditions, this two system cannot help to produce a proper spark from a poor condition of the spark plug. So good or bad not depend only on its own system, but depend on the conditions of your spark plug as well. Okay. So these are all the disadvantages of that two ignition system that we just mentioned. Right? That's why people or engineers start to think about the modern ignition system, right, to help solving all of that problem. Right? The modern ignition system is the electronic ignition system. Right? The electronic ignition system. The principle is still the same because we still need the high current. We still have the spark plug. We still have the plug, the gap that we need the current to go over in order to create the spark. It can go over because of the high voltage that happened. Right? So we still need a high voltage, and that means we still need the primary and the secondary coil in this system. The difference of the electronic ignition system from the conventional ignition system is now in the distributor component area, which is what? Right? For the conventional system, we have the cam for timing, we have the contact breaker, we have the condenser or the capacitor. Right? All of these for the electronic ignition system are disappear. You don't see cam, you don't see contact breaker, you don't see the capacitor in the ignition system. All of them will be replaced by an armature, or the pickup coil. The pickup coil is a stator and the sensor, right? And the heart of the system is here, the electronic control module. The electronic control module, ECM here, right? So since we don't have cam, right, we don't have the contact breakers, it means this system has no moving part, no need to maintenance, right? And because of we don't have the contact breaker point, we have no arcing in this system, right? So it eliminates the problem that we have in the battery coil system or the battery ignition system or the coil ignition system. Okay. Apart from this, right, this system will help increase the spark plug life by 50%. Right? That means what? If your car or your engine use the electronic ignition system, right, instead of replacing the spark plug for every 20,000 kilometers, now you can further use the spark plug up to 60,000 kilometers, 3 times of the previous one, 3 times. Okay, so you spend less on your money, right, to replace the spark plug here. Apart from this, they also give you a better combustion in the combustion chambers, right? Because now 90 to 95% of the air fuel mixture now can be burned inside the combustion chamber. Compare with what? If you use the conventional ignition system, right? You see we have just only 70 to 75% of the air fuel mixture that is burned, right? So it means we can have more power output come out, right? Power output come out from the engine, and we also have more fuel efficiency for this electronic injection system. Okay, so this is the picture of the electronic injection system, right? The part that we still have the same is the battery the ignition switch, the coil, right, and the distributor and the spark plug. Right? You don't see the cam, you don't see the contact breaker point, you don't see the capacitor. Right? It's all replaced by this here, of this, which we have the vacuum advance, and we have a reluctor or the armatures here. This one that will rotate, right? And we have a magnetic pickup signal here. So every time that this magnetic, right, pick up the signal from these armatures, it will send the signal to the ECM here, and the ECM will send the low voltage to the coil, right? And this coil will create the high voltage to the distributor. The distributor will send this high voltage to the spark plug here. Okay, the low voltage from the ECM come out from the battery. Right. So this is the heart. Right. This is the new part to do the timing. This is one, because it receives the signal from the magnetic pickup here. The magnetic here will pick up the signal to and send it to the ECM here. Okay. Not move again. Okay. Another system, right, is just also the electronic ignition system, but we call it the digital system, because in this system we have no the advanced mechanism. The advanced mechanism is here, so right here. We will talk about this mechanism later on in this lecture. Okay, but for the digital electronic ignition system, we have no advanced mechanism here. Right? So we have only the control module here. Right? This is the most important part, because it's all in one in here. Right? And we have a vacuum pipe here. Even though we have no advanced mechanism, but we still have a vacuum pipe here that will connect to the engine. Right? It will receive the vacuum signal from the cylinder, and this vacuum signal will be another information for this ECM to work out, right, in order to create the advanced ignitions, the proper advanced ignition to the engines. Okay, you remember about the advanced ignitions that we used to talk when we mentioned about the start of the ignition, that normally we start the ignition earlier. The word earlier means we do it before the piston go up to the top dead center, right? This is what we call the advanced ignitions. Right? It depends on the condition of the engine, how much that we need to advance our ignitions. Okay, and how much is depend on the signal that we receive from the cylinder, and that signal is the vacuum that happens in the cylinder. Okay, so for the digital electronic ignition system, we have the vacuum pipe here that connects to the engine, right, and receive the vacuum signals from the engine to tell this control module that how much that it will have to do the advanced ignitions, right? And for the electronic ignition system, we have this one to tell the ECM that how much that it, how fast that it have to do the advanced ignitions. Okay. Okay. And in the digital or the ECM, right, the electronic control module, right, we have an ignition map. Right. So this is a map for the engine for the ECM to determine how fast that it have to do the advanced ignitions. Okay, so in here you see this is advanced in degree. That means how fast ignition has to happen. Right? No matter how fast it is, it have to happen before the top dead centers. Okay, so this is the axis for the advanced in degree. It depends on what? It depends on the pressures. Right? Remember we talked about the vacuum signal. It depends on the pressure inside the cylinder, right? Which is depend on the loading on that engine. Right? The loading on that engine will determine the pressure inside the cylinders. Okay, so it depends on the pressure inside the cylinder here and also the engine speed. So if this ECM know how much of the pressure in the cylinders and know the engine speed, right? Then from this ignition map here, they will know how much advance that they have to perform for the ignitions. Okay, so most of the modern car now, right, if they use the ECM or electronic ignition system, right, they will have this data stored in the log, right, so that the engine know, the ignition system know how fast that they have to do the advanced ignitions, right? So every time that the new engine come out, they have to test in order to collect this data here and put it in the log, right, for the ECM to work. Okay. So by sensing the pressure and the speed, the ECM will know how much advance in degree for the ignitions and then actuate the distributor for that advanced degree of ignitions. Okay. Okay. So that is the ignition system for the engines, right? The conventional one is the battery or coil ignition system and the magneto ignition system. Right? The modern one is the electronic or the digital electronic ignition system. Right? The difference between these two is that the first two, right, they have the moving part. Right? No matter it's a cam, the contact breaker point, okay, and the magneto itself. Okay. But the modern one, they have no moving part. Right? Everything is static, no moving part. Only receive the signal from the engines, and then they can provide the ignition timing properly. Okay. So before we go to the firing order, right? Any questions for the ignition system? Any question for the ignition system?มีคำถามอะไรไหมครับ
ไม่มีครับ
ไม่มีนะเข้าใจดีเนาะ Okay, the next one we will talk about the firing order in the multi-cylinder engine, right? Multi-cylinder engine, that means if we have more than one cylinder, right, we need to have a firing order so that our engine will work smoothly and properly, right? The reason we have to have the firing order and for the engine to work properly because we need to arrange the expansion stroke, right, for the different piston in the cylinder, so that when the cylinder have a combustion happen, right, each cylinder will have, when it have a combustion happen, right, it can provide a suitable force distribution to help the engine run more quietly and smoothly, right? And that means you can use a smaller flywheel. Right? No need to have a big flywheel if you provide the firing order in your multi-cylinder engine properly. Okay. The suitable crank angle between any two explosions, because we have more than one cylinder. So when one explosion happen, the second explosion will happen, right? And we need a suitable crank angles between these two explosions in order to ensure that we have the best uniformity happen, right? And in order to get a suitable crank angle here between any two explosions in two cylinder, right? We can achieve this by arranging the crankshaft rotation as follows here. Okay. For the 4-stroke engine, the crankshaft rotations will be what? 720 divided by the number of the cylinder, right? Because every 2 rounds of the crank, we need 1 explosion, right? So it's 720 degree divided by the number of the cylinder. But for 2-stroke engine, right, the crankshaft rotation will be 360 degree divided by the number of the cylinder, because for every round of the crank, we need 1 explosion or 1 power cycle. Okay, so because of this, right, we need to have a firing order. Right? This firing order must be arranged in order to sequence the firing that will take place in different cylinder for a multi-cylinder engine. For SI engine, we have the spark plug. Right? So the distributor will connect to the spark plug at different cylinder according to the engine firing order. Okay, so the advantage of firing order is that we have a proper firing order to reduce the engine vibration, we can maintain the engine balancing, and we can secure a uniform flow of powers. Okay, so these are the necessity why we need to have a firing order for a multi-cylinder engines. Okay, the firing order for different engine will be different. Right. For example, what I can do here, I just can give you the examples. What are the probable firing order for different engine? Right. It's not necessary that the engine have to have a firing order like this. Right. Okay. This is just some examples. Okay. For the 3-cylinder engine, right, you may have, when the explosion happen in the first cylinder, the next explosion will happen in the 3rd cylinder, and the last explosion will happen in the 2nd cylinder. So the sequence of the firing order will go like this: 1, 3, 2, 1, 3, 2, 1, 3, 2. Right? This is for the 3-cylinder engine. For the 4-cylinder engine, which is inline, okay, the firing order may go like this: 1, 3, 4, 2, or 1, 2, 4, 3. And for this 4-cylinder engine, right, if it go something like this, right, when you look at the cranks, the crank will be configured in 2 pairs, and these 2 pairs will be on the same plane. Okay, when you look at these pictures, right, I show you 2 pairs by the color. Right, see the blue color and the red color here. Okay, the blue color is 1 pair, the red color is 1 pair, and this is the crank. Right, and you can see that the crank, all the crank here are arranged in 1 plane, which is the vertical plane. The vertical plane, right? They are all in the same plane. Right? And the firing or the cycle of the engine, right, will go like this. When the first cylinder is in compression, the second cylinder is in power, the third is in intake, and the last one is in the exhaust stroke here. Okay, and by this, you have power for every 180 degree, right? Because what? 4 cylinder divided by 4, right? So it's 180 here. So every 180 degree of the crank rotation, the engine will deliver 1 power. Okay. Okay. And this is for the 4-cylinder horizontal opposed engine, the boxer type engines, right? Again, showing here, you have crank in 2 pair, right? We have 2 pair of cranks, the red color and the blue color. They are all in the same plane, on the same plane, right? The power input every 180 degree. Okay, right? The engine that use the horizontal opposed engine, right? Right? At the beginning, in the previous lecture, I only mentioned the Subaru, right? In fact, we have the Volkswagen as well that used to have the boxer type engine here. Okay. For the 6-cylinder, now it's different, right? 6-cylinder. We have 3 pair of cranks. Right? I show you here 3 color, right? The blue, the green, and the red. And each of this pair, they are arranged in different planes. Right? So in here we have 3 pair. That means we have 3 planes altogether. Right? They are in different planes, not like this one that they are in the same plane. Okay. The firing order may be 1, 5, 3, 6, 2, 4, right? Like this. For 8-cylinder, you have crank in 4 pair, right? 4 color show like this, right? But for this 4 pair, the cranks are arranged in only two planes. That means you have 2 pair in the same plane and the other 2 pair of the cranks in the same plane. Okay, so for example, right, you have the green and the red. They are in the same plane, which is the vertical one. And the orange and the blue, right, they are in the same plane, which is the horizontal plane here. Okay, this is for the 8-cylinder inline engine. Okay, and it's go 1, 6, 2, 5, 8, 3, 7, 4. Okay, and when it works, it may go like this. Okay, the first cylinder is in compression. The second cylinder is in the intake. The third is not in the totally or completely the exhaust stroke. It's just only in the mid of the exhaust stroke here. Right? While number 4 is in the mid of the power stroke. Number 5 is in the mid of the intake stroke. And number 6 is in the mid of the compression. While number 7 is in the power stroke. And the last one is in the exhaust stroke. This is just example of how the cycle that happen for each cylinders, when you have 8-cylinder overall. Okay. This 8-cylinder is the inline. Another 8-cylinder is a V-type, the V-type engine. Right? For the V-type, we have 2 pair of cranks. Right? And to these 2 pair of cranks, they are all arranged in one plane. That means they are all of them are in the same plane. It is an inclined plane here, not horizontal, not vertical. It's an inclined plane here, shown in this picture. Okay, and the power input every 90 degree, because we have 8-cylinder, right? 720 divided by 8 is 90 degree. So every crank angle rotation for 90 degree, right? The engine will deliver 1 powers. Okay. And for the V-type engine, right, how we can determine that this is the first cylinder, the second one, and the third one, because when you look at the V-type engine, you see 2 cylinders on the same plane. Okay, So which one is the first? Right? The rule is that the first cylinder is always taken from the front of the inline and front right side in the V engine. Right? You have to look at the front, and it's on your right side is the first one. So this is the first cylinder. Right? And this is the second, the third, the fourth, the fifth, sixth, seventh, and eighth. Here, this is how they count the number of the cylinders. Right? For the inline one, you have no problem because it's go inline, right? So the first is in the front and the last is in the end. Okay. But for the V-type engine, right, the rule is that the first one is always on the right side. Okay. Okay. So that is the firing order, right? So that you know that when the engine work in cycles, right, different cylinder will have different stroke. They never have the same stroke here. Okay. So that the engine will work smoothly, quietly, and deliver a uniform power output for us. Okay. So any question about the firing order in here? Any questions? มีคำถามไหมครับ firing order ลำดับการจุดระเบิด
ครับขอตรง4 cylinder ใหม่ได้ไหมครับผมแค่ตรง4 cylinder อย่างเดียวได้ไหม
อันนี้ไง inline here inline cylinder here นี่ไงเห็นไหมกะตัวนี้เป็นบ็อกเซอร์สูบแถวเรียง4สูบ4 cylinder นี่ไงทำไมเหรอฮัลโหล
ครับผมเมื่อกี้พอดีไปฟังไม่ทันครับ
ก็ถ้าเป็น4สูบเนี่ยใช่ไหมแคร้งเนี่ยมันจะจับคู่กันเห็นไหมเห็นป่ะคู่กันเนี่ย2คู่ถูกไหมเนี่ยสีน้ำเงินกับสีแดงแคร้งก็คือไอ้ข้อเหวี่ยงอ่ะถูกไหมนะมันจะอยู่ในระนาบเดียวกันหมดนะครับเห็นไหมแคร้งเนี่ยมันจะอยู่ในระนาบเดียวกันหมดในจังหวะที่มันเริ่มจ่าย power มันอยู่ในระนาบเดียวกันหมดเลยนะครับมี power เกิดขึ้นในไซลินเดอร์ที่2นะครับนี่เขาจับจังหวะที่มันจ่าย power นะครับถ้าเป็น4ไซลินเดอร์นะอยู่ในระนาบแนวตั้งถ้าเป็นพวกบ็อกเซอร์ใช่ไหมบ็อกเซอร์เนี่ยมันอยู่ในระนาบแนวนอนตอนจังหวะที่มันมีการจ่าย power แล้วแคร้งก็จะจับคู่กันอย่างเงี้ยนะ2ตัวอยู่ข้างบน2ตัวอยู่ข้างล่างนะลูกสูบแนวนอนนะถ้าเป็น6สูบนะครับ6สูบจังหวะ power แคร้งมันจะอยู่3ระนาบนะข้อเหวี่ยงที่อยู่บนเพลาข้อเหวี่ยงเดียวกันเนี่ยมันจะหมุนตัวอยู่ใน3ระนาบนะเพราะมันมีทั้งหมด3คู่แต่ละคู่จะอยู่กันคนละระนาบหมดนะแต่ถ้าเป็น4สูบเนี่ย2คู่แคร้งมันจะจับคู่กัน2คู่นะแต่ว่ามันจะอยู่ในระนาบเดียวกันถ้าเป็น8สูบเนี่ยจังหวะที่มันมี power ใช่ไหมอย่างลูกสูบ7เนี่ย power เกิดขึ้นเนี่ยจังหวะที่เป็น power แคร้งมันจะจับตัวกันเป็นแบบนี้นะ4คู่แต่มันจะเรียงกันอยู่ใน2ระนาบนะครับเพราะฉะนั้นเนี่ยถ้าเรามองเห็นการทำงานของเครื่องยนต์เนี่ยนะครับนะเราจะรู้เลยว่าต่อให้มีการจุดระเบิดเนี่ยนะครับจังหวะที่มันจ่าย power แข็งจะเรียงตัวกันยังไงนะครับลูกสูบ V นี่ก็เหมือนกันถูกไหมจังหวะที่จ่าย power เนี่ย power ตรงเนี้ยทั้งหมดเนี่ยจะมี power อยู่อันเดียวจังหวะที่มันจ่าย power มาเนี่ยแคร้งมันวางตัวยังไงนะครับอันนี้ก็คือลักษณะของ firing order นะครับ this is the characteristic of the firing order because firing mean powers เรามี power ออกมาเมื่อไหร่แคร้งวางตัวยังไงนะครับโอเค the last one is the ignition timing this is a very important right? Because the chart have to be ignited just before the end of compressions. Right? It have to be ignited just before the end of compression. That means before the piston go to the top dead center. This is a must for the chart. Right? The chart have to be ignited on that timing. Okay. And when the chart is ignited, it will take some time to reach the required rate of burning. Right? Because when the chart ignites, the combustion does not happen suddenly. It needs time before the combustion happens, right? So that time that it needs will be used to determine the time required for the combustion to finish. Okay, so since the chart have to be ignited before the compression finish, right? The time that we mention here, right, is called the ignition advance. The ignition advance. And when we mention about the time in the engine, we always refer to what? The crank angle นะถูกไหมทุกครั้งที่เราพูดถึงเวลาเนี่ยเราจะพูดถึง crank angle เสมอนะครับนะเพราะตรงนั้นจะเห็นภาพชัดเจนนะครับโอเค so ignition advance is to ensure that under every condition of the engine operation, the ignition takes place at the most favorable instant in time. Right? What does it mean by most favorable instant in time? It means it's favor for the engine power, favor for the fuel economy, and give us the minimum exhaust dilution. Okay, so this is the thing that we want to happen, and that's the reason why we have to do the ignition advance. Okay, the advance angle, right, have to be accurately set so that the ignition occur before the piston reaches the top dead center. Right, and since our engine operate on different speed, different loading, right? So we need an automatic system in order to automatically adjust the ignition timing, right? That will suitable for the engine condition. Right? When we talk about the engine condition for ignition timing, right? That condition refer to the engine speed and the engine load. Right? If you remember, we talk about the ignition map. Right? We have the pressure and the engine speed. Right? That will be used to determine what should be the advance in degree for ignition to happen. Okay, so most of the engines have to fit with a mechanisms, right, that integral with the distributor. That means work with the distributor, right, in order to be able to adjust the ignition timing according to the engine speed and the engine load, right? And this mechanism will automatically regulate the optimum spark advance to account for both change of the engine speed and the engine load here. So this gives you the ideas. This picture gives you the idea. When the engine runs at low speed, right, you need low advance. Low advance means you can do the ignition closer to the top dead center. Okay, right, when the engine runs at the low speed. Right, so for here it's 1200 RPM of the engine speed. You do the spark ignitions at 80 degrees before the top dead center, and the combustion end at 20 degrees after top dead center. So that means the crank have to travel what? 41 degrees. So this is the time for the combustion to finish. If you want the combustion to finish at 20 degrees after top dead center, right? So this 41 degree is fixed. So by this, if you convert this 41 degree here into the time, I show you right here, right? For 1200 RPM, 41 degree will be equal to 0.0057 seconds. This is the time for the combustion to finish. Okay, very long time. Okay, long time in this sense. Okay, when compared with the high speed here. Right. So since it had more time, that means what? That means the ignition no need to happen so much earlier because it have more time, right? It have more time. That's the reason why the spark can occur just 80 degrees before the top dead center because they have more time here. Right? This happen at the low speed. For the high speed, right? You want the combustion to finish at the same degree of crank angle. That is 23 degrees after top dead center, the same position of the crank for combustion to finish. Okay, but the engine run at higher speed, 3600 RPM, right? And the crank angle that need to travel is 63 degrees. Okay, so when you convert this 63 degree of travel into the time, it's what? 0.003 seconds, which is much shorter than this. Right? So the combustion have less time to finish. And since it has less time to finish, you have to ignite before. Right? So in this one here, you can see that we have to do the spark at 40 degrees before the top dead center. Right? We have to do it earlier because the time for combustion is shorter, right, at a high speed. So at higher and higher speed, right, we have to do the ignition more earlier and earlier and earlier, right, because of the time getting shorter and shorter for the combustion to finish. Okay, so should not be confused with the degree here. Even though we have 63 degrees to travel, it doesn't mean we have more time. Right? 63 degrees of travel, but we go with higher speed, so the time is less. Compare with this one, 41 degrees of travel, right? Shorter than this one, but the engine run at low speed, so we have more time. Right? So since we have more time for the combustion to finish, the ignition need no need to do it much earlier. We can do it closer to the top dead center. Right? In here is 80 degrees before top dead center. Compare with this one, 40 degrees before top dead center. So this gives you the idea why we need to do the advanced mechanisms, right? Because our engine run in different speed. Okay, so the spark must be timed earlier as the engine speed increase. Okay, so what are the mechanisms that we use to do the advanced ignitions? There are two mechanisms that have to work together, right? The reason we need to have two mechanisms instead of one, because we have two parameters that involve with the advanced ignition timing, right? The first one is the engine speed, and the second one is the engine load. Okay, so that's the reason why we need to have two mechanisms, and they have to work together, right, for the spark advance. And these two mechanisms, both of them are installed at the distributor in here. This is the picture of the distributor here, right? And these two mechanisms are what? The centrifugal advance mechanisms and the vacuum advance mechanism. Okay, so to install these two mechanisms into the distributor shaft, the distributor shaft here, have to divide into upper and lower part. The upper part of the shaft is used to install the vacuum advance mechanism. Right? This is the advanced vacuum advance mechanisms. And the lower part inside here is for installing the centrifugal advance mechanism. Okay, this is what inside. Okay, the mechanism, the advanced mechanism, the mechanical advance system is below here, right? And the vacuum advance mechanism is on the top here. Both of them are connected with the distributor shaft. Okay, that's why the distributor shaft have to divide into portions. The upper portion for the vacuum advance mechanism, the lower portion is for mechanical advance mechanism. Okay, the vacuum advance mechanisms, right, will help the main advance mechanism, which is the centrifugal advance mechanism, right, in order to perform the additional ignition advance, right, or top up the advance ignition advance that provide for the centrifugal advance mechanism. Right? So the centrifugal advance mechanism will provide one certain ignition advance, and this vacuum advance mechanism will top up another further ignition advance timing. Right? So that's why they work together. Okay. The first one, let's look at the first one. The centrifugal advance mechanism here, right, will advance the engine ignition timing in relation to the engine speed. Right? So this mechanism takes care of the effects from the engine speed, right, and convert this effects into advanced ignition timing. Right? It at the bottom, right, or under the lower part of the distributor body under the contact breaker base plate. Okay. Here, show you here. Okay, this is the mechanical advance mechanisms. Right, it consists of the two steel weight here. We have two steel weight here that connect to the plate here. We have the spring here. This spring will try to fight again with the force that come out from the distributor shaft, right? Because the distributor shaft will receive the force according to the engine speed, right? So when it rotates, it gives you the centrifugal force, right? That will try to what? Try to separate these two steel weights together, right? Make these two steel weights going apart from each other. Okay. Right. And this spring here will try to keep these two steel weights close with each other. Right. So the centrifugal force here will try to fight with the spring force to open the gap of these two steel weights. That will result in what? Result in a more ignition advance. Right. Okay. So when the distributor shaft turn, right, it will turn the centrifugal unit, right, which is this two steel weight here, right, and it will turn either the cam, right, the cam is the contact point ignition for conventional ignition system. If you remember, right, we have the cam in the battery ignition system or coil ignition system, okay, or the armatures, right, for the electronic ignition system. Okay, so this centrifugal unit, okay, will try to turn the cam to move faster or slower. Okay, so as the engine speed up, the centrifugal force from the distributor shaft here will throw the weight outward. Right? So you have more opening here between these two steel weight here. Okay. Right. So the weight, when it separates, it will turn on that pivot, right? and twisting the contact breaker cam forward. Right? So the contact point open earlier. So when the contact point open, the magnetic field collapse. Right? The secondary wiring induce higher voltage to the spark plug. Right? So you have the spark plug fire earlier as the engine speed increase. Okay, so when the engine speed increase, the distributor shaft turn faster, and when it turns faster, it will have more centrifugal force, and this centrifugal force will try to separate these two steel weight, right? To separate these two steel weight, and when these two steel weight are separated, it will turn the pivot, which will twist the contact breaker cam forward. Right? So the contact point open much more earlier or faster. Okay. So the spark plug will fire earlier. Okay. So it works together like this. Okay. So to get the proper weight of these two weight here, you have to calculate the pull of the spring or the force from the spring, because it's the resistance force, and the size of the weight here, right? In order to get the proper advanced timing over a wide RPM range, the engine speed length here. Okay, so how much is the weight here, and how much for the size of the spring here, right? That need for this engine, right? So that this mechanism can provide a proper timing for the engine. Right? So when you create the engine, you have to test the engine, get the results, and from that result, you use that result to calculate how much is the weight and how much is the size of the spring here. So that is the mechanical advanced mechanisms, right, that take care of the engine speed. The second mechanism is the vacuum advanced mechanism, right? This will advance the timing beyond that provided by the centrifugal weight during partial throttle open positions, right? That means this advanced mechanism, right, will provide further advanced ignitions, right, that provide from the centrifugal mechanisms, and it will provide this because the engine needs it during partial throttle open position, not at full load, at the partial engine load, because during the partial engine load here, right, the engine have a high vacuum in the intake manifold. Right? High vacuum will happen in the intake manifold, right? So they use this high vacuum to determine that now the engine is under partial loading, right? Partial loading, and it needs more advance under these conditions. Why? Because the high vacuum that happen will draw in less amount of air and fuel mixtures. Right? Remember, the engine is under partial loading, right? So we have less air and fuel mixture to flow in, right? So small amount of the air fuel mixture will be compressed, right? And the compression is less, and that means when it burns, it will burn slowly. It will burn slowly, right? So it needs more time for the combustion to finish, right? If the rate of burning is slow, the combustion needs more time. So when the combustion needs more time, you have to have more advanced ignition to happen. Okay. Okay. And this is the equipment or the component inside the vacuum advanced mechanism, right? It have the pipe that will connect to the intake manifold, right, in order to receive the vacuum pressure, the vacuum signal here. And inside here, we call it a vacuum chamber. Right? And inside this vacuum chamber, we have a diaphragm here. Right? And this diaphragm will connect through the cam here, where the diaphragm link here, right? And all around the diaphragm link here, we have a vacuum spring, right? That will give a force to resist the vacuum force that come out from the engine here, right? In order to adjust the positions of the diaphragm here, right? So that the cam, right, will move properly, right? When the cam moves, it will open and close the contact breaker point, okay? So there is a narrow pipe run from the intake manifold to the vacuum chambers, and inside the vacuum chamber there is a diaphragm here, right? This diaphragm here. This diaphragm here will move left and right according to the force from the vacuum in here and the spring on the diaphragm link. And when this diaphragm moves, right, since it have a link with the cam breaker plate here, so this cam breaker plate here will move, turn left or right, turn left or right, alternately. Okay, this show you here. Right. See, it will turn, sometimes turn left, turn right, left and right, left and right. Okay, when vacuum happen, see the gate. This is the vacuum gate here. Okay, the diaphragm will bend and move the rod connect to the center of the diaphragm, which cause the contact breaker plate to rotate left and right, like this. Okay, and this will move the contact breaker heel related to the distributor cam and advance the ignitions, right? Because the cam will connect with the breaker point. Okay, so open and close the breaker point, and the cam will move according to the motions of the cam plate here. Okay, so when the engine is under load, vacuum decrease, right? So the diaphragm spin back, this diaphragm here spin back, right? So the engine is retarded or delayed to suit the change condition, right? So if engine has more load, the amount of the vacuum in the cylinder will decrease, right? When it decreases, it means more air and fuel mixture flow in, because now the engine is under loading, right? So more compression happen, right? So vacuum is less because more compression happen, right? So the vacuum, when the vacuum pressure here is less, the spring force here is higher, so it will bend this diaphragm back, right? And when the diaphragm go back here, the cam plate move, right? So we have more, no need to do more advanced, right? No advance happen under loading. Okay, and this gives you the pictures, right, of how it helps with each other for these two mechanism. Okay, for the centrifugal advance, right, it gives you an increase in the degree of advance like this linearly, right, because it's proportional with the engine speed. Yeah. For the vacuum advance, it gives you like this, right? So when you top up these two, this is what you get. Right? Total advance show like this. Okay. So the vacuum advance is used to advance the timing in relation to the engine load, because it sends the pressure from the intake manifold. Right? So the centrifugal advance mechanism send the engine speed. The vacuum advance mechanism send the vacuum inside the engine, which represent the engine load that happened. Okay. Okay, so that is for today. For the ignition system, right? Today we learn ignition system, firing order, and the advanced mechanism all together. Any questions? มีอยู่19 คนเองเว้ย Okay, any questions? มีคำถามอะไรไหมฮัลโหลฮัลโหลฮัลโหลฮัลโหลฮัลโหลไม่เงียบเลยไม่มีเลยนี่ถามจริงๆกับฟังกันหรือเปล่าเนี่ย ฟังหรือเปล่าหรือเปิดทิ้งไว้เฉยๆอาจารย์คนอื่นเขาขอให้เปิดหน้าจอหมดเลยนะเนี่ยผมไม่ได้ขอเนี่ยแต่เห็นหลายคนเลยกลัวเด็กเปิดทิ้งไว้เฉยๆกำลังตรวจข้อสอบอยู่นะแล้วก็ไม่ค่อยจะดีเท่าไหร่นะรู้สึกดูแล้วไม่ค่อยจะนั่นนะก็เลยไม่รู้แล้วนะเพราะว่ามันต้องตบมือช่วยกันตบมือนะมันไม่ตบมือมันก็ไม่ดังนะครับโอเค if there is no questions I will end my lecture for today. Okay, so oh by the way, let's see, by the way, next week next week I have something to do. I have to visit the factory. อาทิตย์หน้าเนี่ยต้องไปโรงงานเดี๋ยวผมจะอัดเทปมีเทปที่สอนของ Modern Propulsion เอาไว้นะครับเดี๋ยวผมจะลงในกลุ่มไลน์นะครับวันพุธหน้านะครับลงในกลุ่มไลน์ให้นะพวกคุณก็ดูเทปเอาแล้วเดี๋ยวนัดกันอีกทีว่าจะมาพูดคุยกันเมื่อไหร่นะครับเข้าใจว่าเทปหน้ามันน่าจะเป็น Heat Transfer นะครับคิดว่าน่าจะเป็น Heat Transfer นะโอเคครับวันนี้ถ้าไม่มีอะไรก็พอเท่านี้ครับครับสวัสดีครับ